Hi, in this video we'll be learning how to do velocity or physics in pretty much any game you'd like. You might try to use the built-in physics engine in your engine of choice, such as Unity or UE4, and you may run into problems that have to be dealt with, or if your game is very simple, you can just make your own physics very easily and you know it'll work all the time because it doesn't have any quirks and things that are making it overly complex for your needs. So you may not be familiar with this editor, but it's called Pico 8 and I love it because, well, it's just so darn simple. And that strips away any of the extra doohickeys you might have to learn depending on your program of choice. So if you want to do 2D games, I recommend GameMaker. I do recommend Pico. Just give it a look. You won't be able to make the next a massive RPG with it because it has some deliberate data size restrictions on how big your levels can be, but that's meant to be part of the appeal. It is really good for teaching though because it's very simple, and what I'm about to show you, sorry about that, will be carried through any engine you'll use because the fundamentals are the same. This does involve some light programming, but if you're completely new to programming, you probably should just find a basic tutorial first. This is if you are ready to start making your game, but you want to make a platform game perhaps, and you don't know where to start. So without further ado, let's go. In Pico I can just press escape to get to the editor. It's great and it's very simple, and in Pico I can also draw my own sprites directly into the game. So I'll just make a little man here. By default it uses 8x8 sprites, but you can change that, and if it sounds a bit limiting to you, well, I encourage you to look at the Pico 8 website and just see what kind of things people have made. It's quite impressive. So that'll do. It's pretty ugly, but whatevs. Now, when you're doing programming of any kind, you'll be using functions, and the built-in functions in Pico are function _update and function _draw. Excuse me. Like so. Now, also, if you're used to programming, you might notice this is slightly different. Most of the mainstream languages use braces. Pico goes a step back in time and uses conventions like end to terminate the end of a function or an if statement. And that's fine. If you're into programming, this sort of difference is purely syntactical. It shouldn't matter to you. Well, in Pico, to get something on the screen, we want to have the draw function, which runs about 30 times a second to draw the sprite, which is SPR. I used sprite index number 1 because it's 1 above 0. That's where I drew it. If you're interested, the sprite index is here. And that's 0. We don't start with 0 on Pico because it's reserved for background transparent tiles, and so I draw on sprite number 1. Sprite number 1. Draw SPR1 at, excuse me, lost the screen there, at position 64. If we're working in 2D, we use a screen space that starts with 0 at the top on the y-axis and the z-axis. Sorry, the y-axis is up and down, starts at 0, and in Pico it ends at 128, and x starts at 0 and ends in 128 as well. So this will draw our little man, if we run the program, in the center of the screen. Well, of course, it doesn't erase the background as well, so I'll make it draw a big black square, rect fill at 0, 0 with the top left corner and 128, 128 at the bottom right corner, and color 0 is black. Run that again. Okay, now simple enough. If we've got an if statement here, hopefully you're familiar with those, and in Pico to get input it's btn. So we'll just set up some basic input here. You can probably consider this oops, give me a second to get the screen back. Sorry about that. We'll have the border up there, but at least we'll be able to, I'll stop losing the screen now. Let me see, it goes left, right, so 0 is the first button, which is left. If button 0 is pressed, oh yes, well the first thing to do with your physics is you're going to need a way to store your character's position, otherwise they're just stuck at that one position every frame. And this is common between all the programs you'll be using. In Pico we can just make a new variable called xpos 0, no semicolons in Pico, ypos 0, and we'll draw our sprite at xpos and ypos. That should draw at 0, 0. We'll put it at 12, I don't know, 18, 16, 16. No, I like using hexadecimal numbers. Run. Syntax error. If button 0, then, because we have then. Okay, he's drawn up there because that's where xpos and ypos are set to. Now that we have some variables, we can change them over time by, if button 0, which is left, is pressed, xpos equals xpos plus 1. Now if this seems a bit tedious, this is important because I want to show you just how simple it is to add physics. If you understand this and you think it's a bit slow right now, great. Because if you don't know how to do physics, you're about to find out how simple it really is. Okay, so we got left, I'm pressing left and he's going right because I said add 1 to x position for left and I should have said -1. Let's copy that, make it button 1 and we +1 to the x position, and now we're moving left and right with 1 pixel at a time. So, what else? Well, physics. Now, if you'll excuse me, I am doing this off the cuff and there's lots of interruptions. Okay, just had to kill my alarm there. What's easiest? I could get right into velocity. In fact, I should have added gravity, very first thing. Usually, I used to teach at a college and usually I'd ask the students, alright, we have a man now, and what's wrong? What should the first thing be happen? He's standing in open space, what should happen? He should fall, they say. And that's usually what I do first. So, let's make him fall. Let's add some gravity. If ypos equals, we can do shorthand now. Instead of ypos equals ypos plus 1, we can do plus equals 1. That means add 1 to ypos instead of saying ypos plus ypos. Ypos equals ypos plus 1. There we go, but he's falling, but it's kind of linear, you know? It's not very... What happens when people fall? Anything, really. It increases in speed. This is where physics comes in. This is where velocity comes in, most importantly. And you're about to find out how easy it is. What's the problem? We're adding the same amount every frame, which means he always moves 1 pixel every frame. That's linear. He's going to stay the same speed across as time passes. We need him to move more pixels per frame so that he appears to accelerate as time passes, he moves more than he did the previous frame, which shows him speeding up. So, instead of just adding 1 every frame, we need to add something that itself is growing. And that, guess what, is called velocity. We're going to make a y-vel equals, starts at 0. And instead of adding 1, we add y-vel. But y-vel is 0. It just won't move anywhere, I hear you say. Yes. But this is important. His position is now going to add whatever's in y-vel, and now we can make y-vel increase itself by a certain amount every frame. Y-vel plus equals 1. So this looks similar to before, but it's actually fundamentally different. We're adding 1 and to this velocity every frame, and then we add that to the position, which means the amount we add is going to get bigger every frame. Observe. Too fast. How about we add something a bit smaller, 0.5. Cool. I'm thinking something a bit choppy about this. Never mind, we'll stick with whatever this frame rate is for now. So, how do we feel about that speed? Well, it's a bit fast. I still feel it's a bit choppy. Just feels a bit choppy. I don't know why. How does it look at 60? Looks nice. Anyway, we cut it back. We want to be legit. Anyway, because we're good programmers, we don't want to have what we call magic numbers hard-coded in the code there. So we want to have something we can control in one place and reuse in multiple places rather than having to update some number in multiple places. So we make a new variable called gravity. And we set it to what we thought was a good value for gravity, and then we can add the value of gravity to our velocity every frame. Alright, now we're just about out of time, so I think we'll wind it up there, and in the next step we'll add some collision in so that he hits something, and then it makes sense to have horizontal velocity and friction where he's walking on the ground. So I'll see you in step 2.